Okay, so we've got two trigonometric graphs to transform, and we're going to do 2 cycles of each one. If you want to do more than 2 cycles, because you just love waves, you know, I understand we all want to be at the beach. So do more than 2 if you need to. But you want to make sure you get all the axes labeled and stuff. So what do I mean by that? Your work should look pretty similar to mine. So let's look at my finished product when we're done. All right, so number 1, we want to establish how many transformations are there first on this sine wave. 1. What's this one do? Plus 2 outside. That's up by 2. This 5 affects the amplitude. You can also think of it as a vertical stretch. The amplitude's not 1, because that's the basic one. Now it's 5. Negative is a different transformation. What's the negative going to do? So which way? The negative's on the outside, right? Just like negative x squared on the outside. That flips it like down or over the x-axis, however you want to say that. So we'll say, I'm going to put my period. We need to figure that out. But you guys said reflect it down or over the x-axis, however you want to say that. And the period, how do I find out the period? The standard period for sine or cosine is something you've got to know. It's 2 pi. To figure out the period of this one, Akasha's telling us take 2 pi, the original, and divide by the transformation in here, if there is one. If there's nothing here, if it just says sine of x, period's just 2 pi, right? So if you divide by 4 pi, that's pretty nice on this guy, because what cancels?
The pi's.
Pi's, 2 over 4 is 1/2. That means this wave is going to complete a wave or a cycle every 1/2. Does that mean the wave has been crunched down and it's going to be real bouncy, or has it been stretched out and it's going to bounce languidly? Crunchy, yes. Going for the Doritos on this one. Okay, so we're going to go up by 2. So let's start putting this information together. So up by 2, I think if you have a vertical thing with waves, you want to do that first. Okay, so I'm going to go up by 2, try to make it clear. No, that's not 2, I need to be better than that. Let's see, that's like the same scale right there. Alright, so we'll get a nice center of our corridor at y equals 2. Mine's still bent, I don't know, I always bend them. Alright, so from that we're going to go up and down how far? Amplitude says how high up and down to go, so we're going to go up and down 5. How long is it going to take us to finish a cycle? Remember, this is going to be really crunched down. It's not going to take very long, just 1/2. So I'm going to exaggerate and say that this is, I don't know. I'm not going to exaggerate. Let's not exaggerate. Let's try to draw this to scale. It's going to be hard, but we'll try it. So if this is 1, then I'll try to measure this. So this is about 1. That's about 2. So how many cycles of the wave are going to be finished by the time we get to 2? 4 cycles. There's going to be 4 waves already done by that point. So it's going to be very bouncy. So you guys said up and down 5, right? And sine, does it start in the middle? Or does it start up? Sine starts in the middle. But this one doesn't go wave up, wave down. That's regular sine. This one is reflected down. So it's going to wave down, wave up, and that wave down, wave up process is going to take how long again?
1/2.
1/2, so I'm going to have to make it really bouncy here, right? So I'm going to wave up 5, so 2 plus 5 is 7, so let me get this guy to go higher. I've got to plan ahead sometimes. 3, 4, 5, 6, 7, we'll call that good. Down is going to be -1, -2. It's going to go down to -3, right? So we're going to start in the middle. We're going to wave down, wave up. So wave down how far?
3.
All the way to -3, and then wave back up all the way up to 7. And it's going to be finished at 1/2. So that's the finished spot. And in the middle, it's also going to hit. So you guys can see it's going to be kind of hard to draw this one. So I'm going to wave down, wave up. There is 1 period or 1 cycle. I'll try to do that again. So I'll be done at 1, and I'll hit in the middle, wave down, wave up. There's 2 cycles. That would satisfy the directions, but I don't know, we're going to do a couple more because we feel wavy today. So I'll be done at 1.5, wave down, wave up, wave down, wave up. You guys can see how bouncy that particular sine wave is. Okay? Let's have a look at number 2. Number 2 has how many transformations? 2 transformations. Coincidentally, we have the 2, it's one of the transformations, and then the plus pi is the other one. What's the 2 going to do? It's going to stretch it, make the amplitude of the wave be a little bit more, right? 2 instead of 1. If there's nothing there, you're going to put the amplitude's 1, not nothing. So if it was nothing, there'd be no wave, Jensen. You got me?
I got you.
Okay. So, what's the period on this guy? The period has not been transformed because there's nothing multiplying here on the x. So the period's just plain old 2 pi, the original. What's that plus pi do? It's inside is opposite, plus inside is left. So, like I said at the end of last period, I think some of you guys left a little early, so hopefully you watched the video and started this weekend. If you have what's a left or right in trig land, it's a little bit harder, so I'd recommend just ignoring it and then doing a separate wave. So I'm going to do this in 2 steps. If you don't, you're going to have to think really hard. So, and especially once we get to harder trig graphs, it's going to be really hard to think. If you include this phase shift, that's what this is called, if you try to do it right away, it's going to be tough. So I'm just going to ignore the plus pi. I'm just going to graph 2 cosine of x, okay? So 2 cosine of x, let's see what that looks like. This period's 2 pi, so I'll say it's done right there. Go 1 more there, and I'll just do 3 cycles. It's going to go up and down 2. Is it going to start in the middle or start up? It's cosine, it starts up. How high? 2. So it's going to start up, and how far away is it going to end? 2 pi. It's going to end up in the middle at pi. It's going to be down. Down, up. Up, down. Okay, you want to take some time to draw these. Try to make them a little bit nice, otherwise there's going to be issues when you try to draw. So I'm going to draw it nice and smooth. It's probably decent enough. Is that the final graph I wanted to draw, though?
No.
So that doesn't have the what? That's just 2 cosine of x. 2 cosine of x plus pi moves every point in that curve which way? Left by pi. So you can try to think about them all at once in your head and think about moving them to the left by pi. But I just recommend picking a couple that you know. So like this guy, instead of being at x equals 0, it's now at negative pi. This guy, instead of being at pi, is now left pi at at 0, x equals 0, y equals negative 2. This guy, instead of being at x equals 2 pi, is at pi. And then once you've got enough, you can just draw the new curve and connect the dots. Yeah? So I think that's enough for me. It's up to you if you want to do more of them. So I can see that really this is going like this now. I don't know if this guy, that guy's there, this guy's going to be here. Yeah, it's something like it's going to continue the pattern. This guy's going to be up here. So if you do that, make sure you clearly label which one's which. This one I should label as what? And I'd use 2 colors on phase shift at once. What should I call it? That'd be good.
Call it red line.
You've already got a name for it though.
GX.
This one's G. What would I call blue? F is a good, I like that, that's good, because that's like the beginning one.
That's a good.
But I don't see anything about F, so unless you write this down on your paper, that you're calling F 2 cosine of
You
X,
just put like
I'd either call it 2 cosine of X,
or just
I don't know about just X.
Shut up.
You could also write something like, that's my guide,
okay.
okay? So, as long as you clarify it.